Hi, guys. Wow, you are a lot of people in a small room. Well, it's not that small, but awesome to see you guys here. I feel a little strange standing besides this scene, actually, but we'll make do, right? Yeah. So a couple of months ago, actually it was last year, me and my husband, we went to New York, and we visited the Madame Tussauds that they have there. And they just released a VR experience where you could actually become a Ghostbuster. Needless to say, we had to try it, being that both me and my husband are really super geeky. So we got to try this, and we got into a room, we got teamed up with 4 people, and we got the guns, and we even got the proton packs. And at first, and I'm a little embarrassed to say this, but at first I was like, shoot, this is really heavy. Why are they making it so realistic? It was the computer, right? Yeah. So we got in, and they were tracking us the whole time, so we could actually see our team members in a virtual world. Well, represented by an avatar, but it was still pretty cool. And there was some ghost hunting to be done, obviously. We're Ghostbusters. So we go into the apartment complex in New York to fight ghosts. And we do a lot of cool stuff. We get to open physically doors in the virtual world. We get to go on a real elevator ride. Well, at least we thought it was real. Obviously it wasn't. And there's one time where I forgot to shoot, or well, actually I missed to shoot one of the ghosts, and it went right through me, and I could really feel it through all my body, because we also had vibration vests on. So that was pretty cool. And things starting happening, and there's a ghost, and there's a fight, and the whole front of the building is blown off. So there we are, up really high in an apartment complex in New York, looking down on the streets of New York. We could even feel the wind blowing. And then in our ears we hear the dispatch saying that there's a problem in the room next door, or actually not the room next door, it's actually the building next door. And they were like, yeah, you need to go over to the other building using this fire escape plank thingy with handles. And I'm just a tiny bit afraid of heights. So I was putting my foot on that, and I was like shaking, and you could feel the plank, basically. You could feel it wobble and creak, and I was like, nope, I'm going over like this. So I cheated. Otherwise, I would not have made it, I promise. But there was also glitchy avatars, and the tracking was a little bit off. At one point, I turn over to my colleague, or well, teammate, and she has a gun going through her stomach. Didn't seem that practical, actually. It's not how I would shoot a ghost, but what do I know? I missed, right? But don't get me wrong, this material they had, it was fantastic. So if you ever get the chance to try it, I encourage you to do so. But my point with this story is that the material was good, but it could have been so much better had they just done a few more tweaks. And this is why I'm here today. There's a lot of tweaks out there. And we're living in such exciting times nowadays. There's devices coming up left and right every day now, it feels like. And with that, we also get hot new ways of augmenting our experiences. And this also means we have new ways of interacting with your applications. And UX is becoming more important than ever, because if you're a little bit off, you will actually make your users physically ill. And that kind of sucks. So I will go through the differences between AR, MR, and VR, and we will also scratch the surface on where we can go wrong and how to fix it, and a few pointers on, well, to keep in mind. And I know that the platforms differs a bit between augmented and virtual reality and things like that, but I think that there are still lessons to be learned for all of us in all of these platforms. My name is Jessica. I run a startup with my husband, and we do Windows development, but since last year, we've been doing 80-90% of HoloLens development and things, which is super fun. I do most of the UX and UI stuff, and Jimmy, he does most of the heavy developing stuff because he's so much better than me on that. So there's a lot of realities out there. And one would think that these realities are fairly new to the market, right? Both virtual reality and augmented reality has actually been around for a while. So already back in 1584, I did not misspell that, 1584, there's a scientist who writes a paper and he says, how we may see in a chamber things that are not. So how we may see in a chamber things that are not. And this is the title of the first known description of the Pepper's ghost effect. Now, Pepper's ghost is an illusion trick that has been used in theaters, in sideshows, amusement park, TV, even in shops today you can see this. And what we know is that it has definitely been in use since 1862. And this, I argue, is a form of augmented reality, and I will get back to why in a bit. So if we jump ahead of time and we look at the early 1960s, we got one of the earliest multimodal immersive machines called Sensorama. Pretty cool thing. It's a mechanical device, and you sit down and you watch a movie, and there's stereoscopic 3D, which is kind of wide angle, and there's air that can be blown in your face, there's scents and aromas you can trigger during the film, and there's also body tilting involved, and this was the 60s. In the late 60s, Ivan Sutherland, did you just lose the mic? No? He made the what is widely considered the first head-mounted display for virtual and augmented reality. And this contraption has my favorite name ever. It sounds like taken from a superhero movie. It was a sword of Damocles. I mean, come on, who wouldn't want to go in battle with that name? So if we jump ahead again to the 90s, we got virtuality, and that is those large gaming machine thingies that we could find in arcades. And then things are going to speed up here. So we get Google Glasses in 2013, we get Google Cardboard, we get the HTC Vive, we get the Oculus Rift and the HoloLens and the Meta, and now things are going to happen basically every week. But what are the differences in these realities? Well, as I said, augmented reality has come and gone a few times, but when Pokemon Go came around, it really became mainstream. How many of you guys have tried Pokemon Go? Is it a thing here? Yeah, most of you. I haven't, because I'm a stubborn Windows Phone user. Yeah. So I need to watch you guys collect them. So augmented reality is basically when you overlay the real world with digital information, or augment, if you will. But you do so through a screen, like a phone or an iPad or whatever, and you see the real world and the digital world through the screen. And you can't really interact with the real world and between the real world and the digital object either. So this is from the exhibition area on Madame Tussauds in New York, and I find this a bit funny because they are portraying Slimer the ghost, and they're using Pepper's ghost technique. I have a bad sense of humor. So this is actually what they were talking about in 1584. It's this technique that we have been using since 1862. Fantastic, isn't it? Okay, granted, today we use a screen instead of light thingies and stuff like that, but it's still pretty cool. And yes, he did just take a selfie. Of course, there are more advanced augmented reality units as well. This one is, well, these two are DAQRI. That's the smart glasses and the smart helmet. And these are aimed towards industrial use. So they have ruggedized screens, visors, and they have thermal cameras and stuff like that. And I have yet to try them. We try to buy all these devices, but this one is kind of pricey. This is $1,300. So we're still waiting. And also, I mean, that helmet is a hard hat, and I don't see much use of that at home, but still pretty cool. But this is augmented reality. So virtual reality is when you immerse yourself into the virtual world, or the digital world, if you will. And I mentioned the 90s arcade earlier. This is what it looked like. So he's in this, encased in this circular contraption, and this, my friends, is so dangerous that he even has a belt. So he's strapped in inside this contraption. But I also love this picture because the woman is pointing in something, telling him what to look at or something, like he's going to see that. And this is more of what it looks like today. So look at this guy over here. And he's so immersed in this game, he's actually leaning towards the virtual pool table. Yeah. So perhaps they were onto something in the 90s when we were strapped in. Not a bad idea. Yeah, I could totally do that. So this is merged reality, because we cannot be satisfied with just one MR, right? We need to have a lot of them, so it confuses us. So this is merged reality. This is from Intel. And it's basically virtual reality where you can see real objects. In this case, it's your real hand in the virtual world. And then we have mixed reality, the other MR. And I love this game, it's super cute. I shouldn't like games. I only play children's games, I don't know. They're easier. So, I'm sorry? This game is called Young Conquer.
What is it
about? What is this about? Okay, so this game is about this space squirrel thingy, and he is going to do some chores for you, and you go on an adventure, and he collects money, and he gets you get to tell him, go and pull that plug and plug it in here instead, and you have small, cute stuff like that. So that's basically the game. It's available on the HoloLens in the Windows Store. Yes, it is, and it's free, and super cute. So Young Conquer. So anyway, mixed reality is when you bring the virtual world into the real world, and you see the real world with your own eyes and not through a screen. And the virtual objects can actually interact with the real world. So in this case, the little squirrel is actually jumping off of the chair onto the table because it knows where the table is and it knows where the floor is and things like that. So it can actually interact with it. And the mixed reality description is changing a bit, and I will come back to that in a bit because, like I said, we cannot have just one mixed reality, right? Or MR. And mixed reality is both tethered and not, so there's different kinds of them. This is the Meta 2. It's one of the few mixed reality headsets out there. And basically, this uses Pepper's Ghost. Again with the Pepper's Ghost, right? But it's still fantastic that we've been using this technique in 1862, and now we use it to see holographic apps. So how this works is there's a screen up here which reflects down in the visor. And the Meta is tethered and has to be connected to a computer. And then we have the HoloLens. It's completely free of cords, and you don't need a computer for it. Basically, you're wearing your computer. And the HoloLens has also a see-through visor, but it also has transparent lenses. So this is a different technique. So this lenses, above them, there's light emitters, which bounces the lights between the lenses and into your eyes. A little bit like this table looks white to me because how the light is actually bouncing off into my eyes, and that's the same technique that the HoloLens is using. So it bounces in the, well, it sends in the lights into my eyes as if the hologram was standing here and being white or whatever. So it's kind of cool. It's basically magic. So on the Meta, you can do a little bit more minority report thingies. And on the HoloLens, you have to use predefined gestures to interact with the holograms. But the holograms are super solid. So if you're more into the cool looking effects, go for the Meta. If you want really, really solid holograms, go for the HoloLens. And also no computer. So that's good. Oh, and both of these are still in dev kit. So we're still just getting started here. So Windows Holographic is the possibility, or gives us the possibility to run Windows apps in the HoloLens, and it's also being made available for VR. So basically, you can develop a UVP app and run it on your favorite VR headset. Or you can also run your HoloLens apps or your holographic 3D apps in your VR headsets. So that's good. And Microsoft announced a while back that they are collaborating with a lot of manufacturers of VR headsets. And they are doing this to bring the inside-out tracking from the HoloLens to the virtual world. And this, I think, will be so amazing because you don't have the need for external trackers, and everything will be up in your face. I was going to say, but Acer is actually the first one, and it was released last month, I believe. I did try it. It was pretty good. Still a developer kit, so I mean it can't be too hard, but it's working pretty well. And these guys will also work with the Xbox. So that's a neat feature. Because this will mean that we don't have to bump into walls or chairs, or in my case, the cat, every time I'm in VR, because they will keep track of that for you. So, now that we have identified what the differences is, it's time to get to work and identify the experience. And here you need to think kind of long and hard on what type of experience you are developing. I tried the NASA's Destination Mars a while back on the HoloLens, and you go into a room with a group of people, I think we were 8, and the room is pretty dark. It's black walls, black ceiling, black floors, and there's a little squiggly lines here and there to make the HoloLens actually understand where it is and can keep tracking. But the cool thing is that they are actually using images from the Mars orbiter and the Mars rover. So we could walk around on Mars. And also Buzz Aldrin was there, virtually, but he was there, telling us about stuff. And you could go and oh wait, there's a crack in the rock bed here. Why is that? And I click on that and they will tell me that, well, it used to be water on Mars and the ice froze and expanded and now there's a crack. So that was interesting. But I would say that this had been so much better suited for a virtual reality experience. It does not take advantage of anything of the HoloLens platform, and it completely changed out my actual world to a digital one, so basically virtual world. So this is what I mean by you need to identify the experience. Are you going to change out the whole world, or are you just wanting to augment a few things and stuff like that? Because it will be meaningful in the end. So being that it's popping up new devices from left and right every second now, basically, it's important to also identify the type of tech you are going to run your app or your game on, because there isn't one VR experience anymore, and there isn't one AR experience anymore. I mean, you can imagine the differences between AR on your phone and the DAQRI. So you need to think about where you want to be, what tech is going to be used. In the 2D world of things, we can design one app and run it on basically all platforms with little or no harm. I mean, the worst thing that happens is that I'm on my Windows phone and I get an app that actually looks like an iPhone app. I can still use it. But in the 3D world of things, it's no longer a good idea, because the solution you write and the hardware you choose to release on make all the difference in the user's experience, and also can prevent cyber sickness. So when we know what tech we're using, we need to identify the play area. And I say play area not because you need to do games, but it's easier to have one word for it, so I call it play area. So there's a few different types of areas to work with, and the experience differs a bit from those as well. So first up, we have the stationary area, or almost stationary, where the user sits by the desk or standing still or something like that, but the point is they're not running around. And we have the location-based version of room scale, and you can have a custom rig set up. Let's say you have a museum, and you have a permanent physical chair nailed down to the floor, and you overlay that with a throne. So people can walk around in castles, like from 1500s or something, and then they can sit down in the actual IKEA chair, but when they sit on it, it's actually a throne and they can sit there and be royal. And also the Ghostbusters experience, that was also location-based room scale. Then we have the more common room scale, which is when you can walk around freely as a user, well, in the tracked area. So the HTC Vive, for instance, or the Oculus Rift. And the actual tracking area also differs between these two platforms. And I think the Vive can track about 15 by 15 feet, and the Oculus Rift has a lot less tracking area, and it also depends on how many cameras you buy. So that's also an issue. And another thing you need to talk about, is when you are developing for tethered devices, which VR mostly are, and also the Meta is also tethered, you need to make sure that the user doesn't yank the cord out of the computer. Or, as something that I would totally do, yank the computer down to the floor and break it. Just ask my husband. If you're developing for the HoloLens or the DAQRI or a phone, you don't have to care about those things, but it's a good idea to keep in mind that if the cord is 3 meters, don't let them run 4 meters in the game. Now the HoloLens is using something called world scale. So it has built-in sensors. It has 4 cameras, which is environmental sensing cameras, which constantly is scanning the room. And it's looking for things like, where's the table, where's the red vase, where's the curtain, where's the floor, where's the stain on the carpet, and things like that, to keep track of where you are in the room and where the holograms are in relation to you. So, when we're done and we have defined the play area, how does the user move around in this predefined area? Well, we have a gamepad. That's a classical way of gaming, right? Works on most platforms. We have teleportation, and this is a very common way to use when you are traveling longer distances. Like in the lab on the HTC Vive, for instance, you use a controller to project a beam on the floor, and then you click, and you go there. Kind of neat. So that's the beam you have there. And in Batman Arkham VR on the PlayStation, they use a small controller and a bat signal, or a bat symbol, if you will, to show where there's predefined areas you can go to. So both of these are very easy to use, but in my experience, the lab version, even if it's actually giving you more precision, it takes a little bit more learning than this does. But then again, you don't have the exact freedom when you only have predefined areas, so you need to weigh that. Then we have physical movement. We can move, right? So the user walks around freely, and it can be a really good idea to shorten the actual walking distance in the game, so the user doesn't have to walk a couple of miles to get to the next village or things like that, unless that's part of the plot, of course. So decide if you want to use one of these or if you want to enable a couple of them, basically. So now we can move. It's time to talk about how we interact with the world. So with all these new mediums, we also have new ways of interaction. It can be human interaction, but it can also be new types of controllers. And some of these are not necessarily super new, but if we compare it to 30 years of 2D navigation, it is. So the most common one is controllers, and like I said, we have the gamepad. The HoloLens comes with its own clicker. The HTC and Oculus Rift has their own versions, and you can, well, first time I saw the Oculus Rift controller, I thought it was kind of funny looking, but it's really, really sleek. I like it actually more than I do the HTC Vive controller. And also, since many of these devices are Bluetooth enabled, you can also use your regular mouse and keyboard. Now, that might not be the best version if you're going to be in a VR set where you actually can't see what you're typing, if you're not really, really good at typing, that is. But they can use it. So don't take it for granted, but know that it's there. And I actually have a story about that. My husband, the first time he got to try the HoloLens, I have yet to try it, this is a couple of years back, he came back and he was out of breath. He was like, the mouse popped out. He was hysterical. So I was like, calm down. What did you get to see? Was it cool? And he was telling me about an architectural demo. So he stood by a table and a computer, and he could manipulate a building architectural demo. So it was basically SketchUp, I think it was. So he could grab the roof of the building on the computer, and the hologram over here would raise the roof at the same time, which was pretty cool. But he thought that, okay, so yeah, I can see the hologram, but why am I still stuck at the computer? I have a computer on my head with a HoloLens. Why am I not here? So he actually told his instructor, and his instructor said, okay, put your mouse cursor up in the corner of your screen. So he did. And keep moving. So it popped out into the real world. And this is apparently the best thing since sliced bread, because all of a sudden he could be where the action was. So the mouse cursor in the real world, that's the thing. So my point with this story is really that some users won't use mouse and keyboard, but if you enable it, you will have people like Jimmy raving about it for years because he's still talking about this. For the devices that has hand tracking, like the HoloLens and Intel and a few others that are using leap motions on their headset, you're using gestures. So I told you before that the HoloLens comes with a couple of predefined gestures. It's basically click and bloom. That's it. And what happens when you click? Well, it's a click event. So that's up to you, right? Nothing different there. Some games and apps have implemented their own gestures, like the Superman flight. Pretty cool. I do approve of the superhero part of this, but flying around like this for an hour, maybe not. So my point is, this is just a word of caution that when you're using your own non-standard gestures, be careful. And I've been demoing the HoloLens for a couple of years now, and probably for around 3,000 people. And I have seen them all. I kid you not. So the gesture is, you start like this with your finger up, you pinch them together and lift it again. Seems easy, right? I've seen it all. I've seen the angry duck. I've seen the Pac-Man. I've seen the worm. And I've also seen move every single finger but the one I'm telling you to move. So what's easy for me, I mean, I'm a power user, I use it all the time, might not be easy for your users. So, unless you're implemented Spider-Man's web shooting gesture, which I'm all for, be careful. Yeah, I like superheroes. It's a thing. So, gaze. This is basically where you look, and if the device doesn't have eye tracking, it's actually where your head is pointing, like this. And it's a really good idea not to execute on every single move on your gaze, like menus popping up when you're just panning the room. And even worse if you actually have sound attached to the menus. So in the beginning, users actually need to get acquaintance to this. So this is a fantastic world, and they might actually be, wow, look at that. And slow down a bit. So if you think that, well, if they look at something in 2 seconds, I need to execute. If they're a beginner and they haven't tried your app, or they don't even have to be a beginner, maybe you did a fantastic job and they're looking at this marvelous world you developed, then you might need to actually make sure that they want to execute on that. So an example could be that you have the user look at the menu item and you pop up the actual triggers to the side, so then they have to look at that and select that. So you make sure, or you can have it up and down or whatever, but the point is, don't execute on every single look they give you. Voice is another way of interacting, and you should really make voice your best friend. Most people already know how to talk. You don't have to teach them. So that's good. So use it whenever possible and suitable, of course. It's actually so much easier to just say, take a picture, then navigate through the menu doing so, either with your hands or your controller or whatever. I have a question?
Doesn't it provide problems with localization?
Doesn't it provide problems with localization? You mean, oh yes, yes. Yes, accents in different countries, yes, it is a problem. And that's something that you have to handle in your own app. And it's also important to think about language design. As you said, there's accents and there's different things, and there's different words for the same thing, and that's actually a whole other presentation, because it's really important to talk about those things. But if you do an English game, then usually it's no problem. Or if you stick to things like take a picture and select and things like that. Or, as I said, you can also handle that yourself. Did that answer your question? Awesome. So like I said, that's a whole other presentation. There's a really good amount of resource about voice and design for languages on the web. So I encourage you to actually look that up if you're interested. And this is also why services like Alexa and Cortana and Siri is so popular, and more devices get voice integrated. And I come from Sweden, so I know about the, the language things. We don't get Cortana and Alexa in Sweden, so we have to import it or use English. The HoloLens, for instance, has an array of 4 microphones, so it can sort out your voice from your friend's voice and the surrounding sounds. And this works really, really good in most environments. And that goes for other devices as well, of course. But with all these new ways of interacting with AR, VR, and MR, it might be tempting to design something that looks like this, or from Star Trek, or something like that. But this might not be a fun thing to do for 8 hours a day. Well, at least for longer periods of time. And I don't say you shouldn't use cool stuff like that, like the Superman flight or using the Force and things like that. I'm all for it, but I'm saying use it sparsely. And it will also be a better effect for the user if you use it sparsely, otherwise they get bored of it. So, now that we know how to interact with the world, how does the world interact with the user? So being that we are in such an immersive world, even if we are in augmented reality, there's a lot of cool holograms and stuff like that, it gets harder for you to try to communicate with the users. So we need to work a little harder to get the attention sometimes. And we also don't have set frames to anchor our information to. Like in web pages, we have the menus items on one side and things like that. Because now the canvas is all of a sudden 360 degrees. Well, you could just anchor stuff to the camera, so you see it all the time, and it moves with the user, right? Be careful with putting too much things in faces of people, because this is not a nice feeling. And also, it can actually obstruct other things in the app that you're developing. And lastly, it can also make you cyber sick. So we don't want the information on screen all the time. So unless you're actually designing for Iron Man, or the information doesn't have to be shown all the time, use contextual menus and actions. But also be careful of doing that. The Destination Mars demo, they had a really beautiful solution to this. It's a simple one. I'm looking at an item over here. A menu pops out, and I interact with it, and the nested menu comes up, or the sub-menu, and I interact with that, and it changes to the next level of items again. But I've seen really beautiful examples. I mean, super nicely designed. I look at the item over here, and it swooshes out with a really nice animation, and there's these orbs going around. But the problem is that if I'm looking at this over here, and my menu item is over here, I've lost the context. So that's also a problem. So you need to think about the relationship between the context and the nested menu items. If you have information or labels that you need to have for describing something in the 3D world, put it on the same z-axis as the actual item you're describing. This will make so much more sense to the user, even if it's actually obstructing a bit from certain angles. So how do we get the user's attention then? There's a few tricks here. Visual cues are a really good help. It can be glowing or pulsating over or around the thing you want to draw attention to. But make sure you don't do it just once. Because if they are turned around looking at the wondrous world they have discovered, they need to have an option to actually see it. It could be that you're actually pulsating at first, but then you just have a small aura around it, or something like that. So with all these XRs, as we can call them, we also have to apply spatial thinking, because we have this completely new canvas. And one thing will become more important than ever, and that is audio. If you have multiple objects in your game or app that can make sounds, make sure you actually attach the audio controller on the items, because that spatial audio will help the user find their way around or find your items or whatever and grab their attention. So many of these devices, they are using gaze to navigate and not your physical hands. So another thing that will give us more physical sense about the game or object is a phrase I first heard John Howard say, and it's haptic audio. And I know you can't really touch audio, but if you give your surfaces and objects a lifelike sound, it will almost become tactile to the user. Are the object hollow or solid? Is it made of wood or metal? And these things can actually help the user as well if they can interact with the game or with the game object or not, or if they can move it and things like that. So designing for the 2D world, we have lately learned that we should be authentically digital. We should not be imitating the real world. But in the 3D world of things, that's exactly what we should do. So let me see if I have this sound on. Yes. This video is an example of why haptic audio is a great idea. And we have no sound at all. And no technician. Well, okay, so now he's walking on snow. I'm lucky it's actually narrated. Well, you get the idea anyway. So the same thing goes for audio cues as to visual cues. And we need to make sure that the user actually knows that something is about to happen and that they can trigger something to get to the next level or what it can be. So let's say you're playing a game and you're standing in an antique shop. And you want to make the user aware that something is going to happen over here later on. So you have a mouse running over the glass counter and you can hear his little paws. Is it paws on a mouse? I don't know. But you can hear his tiny little paws. And he's squeaking. Could grab their attention. But if they're over here admiring, completely mesmerized by your antiques you designed, they might miss it. So a good practice is to use steps of 3. So first you have the first mouse run over the counter, and then you can have another mice or two run over again, which means, well, something is about to happen any second now. And then the whole herd of mice come running from the bad guy coming to do bad guy stuff in your antique shop. They won't miss that. So audio is important for the experience. And it can actually also help with the field of view, making the world feel larger. Like in Fragments, and this is another HoloLens game. This is my favorite game ever, I think. So you're basically a memory detective. And you, at one point in the game, we are having a holo call, so basically a Skype call with holograms, where we're comparing notes to try to find this missing boy, and we're talking about the case, and all of a sudden I hear something over here. So I turn around, and there's a guy sitting in my couch. And I'm not talking about hovering a little bit above as if he was sitting in the couch. He is sitting in my couch. Really cool. I actually had a friend try this in his kitchen, and they don't have chairs and tables in the kitchen. They usually jump up on the counter. Where did you think he gets? He jumped up on the counter. I mean, you don't sit the same way on the counter as you do on the couch, so that's pretty cool. But back to the sound of things. I was over here having a call, but my brain told me that my world is this large because I had the sound over here. So this word, VR is sometimes, as a joke, called vomit reality. How many of you have ever felt a little nauseous or getting a headache or something from VR? Yeah, a few. So this means that UX and UI is more important than ever, especially in VR, because if you're a little bit off, you can actually make your users sick. And the fact is that we have not cracked the nut that is motion sickness. We have theories and some solutions, but it's still a fairly new medium, and actually both the tech and the UX research is ongoing and developing right now. So we are writing the user guidelines as we go along. But there are three prominent theories to why we get cybersick. So one of the theories is poison theory. And this is based on that we get hallucinations, which the VR world can be interpreted to. Our body goes into survival mode and wants to expel whatever poison we still have left in our stomachs. And this one is called postural instability. So this is based on that the main goal of the human body is to remain stable at all times in the environment. So prolonged postural instability, like this guy is going through, can result in cybersickness. So quick changes in the VR world is said to give postural instability, therefore, poor guy. And the third theory is sensory conflict. So this theory is based on the conflict of two key sensory systems, the visual and the vestibular system. So they provide information about the person's orientation and perceived motion and the mismatch in these senses. So the vestibular system says that you are stationary, but the visual system says that you are moving, and we have a conflict, and that might result in cybersickness. So we have to work around this as much as we can. What we also do know is that there are a lot of individual factors to cybersickness. For instance, children between the age of 2 and 12 are really, they have the greatest susceptibility to cybersickness. And when they grow older, that rapidly decreases. Women had, in general, a wider field of view, which makes our more perceptive to flicker and therefore also cybersickness. And research has also recently shown that the female hormone can also be affecting the susceptibility of cybersickness. Underlying illnesses, like are you having the flu or are you hungover, that can also be affecting. Are you standing up straight, or are you slouching, or are you sitting, and stuff like that. All of that stuff also has an effect. So things like latency and flicker can induce cybersickness. And this is why it's so important that you actually test your things on the actual device that is going to be used and not your monster developing machines, okay? There's a difference. How is the user moving around? Are they riding a train? Are they riding a car? And things like that. Are they sitting down in a couch and not moving at all? Well, sure, you could actually try to safe it and always keep the user stationary. But first of all, that won't solve all the problems. And second of all, what's the fun in that? You have made this wondrous world and you're forcing the user to sit down. And there's not one magical solution that will work for everybody. What works for me might make you guys sick and vice versa. So if you have the time and the budget for it, you could enable one or more, well, preferably more ways of navigation, because then the user can actually choose whatever they feel more comfortable with. And also your game or app will be available, or can be compatible, I should say, with more devices as well. Free roaming games are fantastic. As I said, you have this wondrous world you can walk around in, but it can cause cybersickness. And you could try to fix that by giving the user a virtual body. That tends to help a lot, if it's done right. If the actual body doesn't correspond with the user, like the movement is a bit off, or you're walking through a door or something like that, or you're rendered a couple of inches below the floor and things like that, it can actually make things worse. Or like in the Ghostbusters game where she actually had a gun through her stomach. Some people tend to think that, well, gaming in a third-person view helps them to not become sick. So that's something you can try as well. If you put your user on a vehicle that is moving, especially on a curve or where you have unpredicted turns and stuff like that, the user may very well get sick. A friend of mine, he's called Max, he made this super cool game for the HTC Vive called #Archery. And at one point in the game, you are standing up on the back of a truck, and it's moving and it's turning and doing whatever trucks do. And when they release these as a beta, people come complaining like, we're getting really sick from your games. And he's a professional developer, game developer, so he knows what he's doing. But all of a sudden, this game made them sick. So what they did was they locked down the rotation of the tracking space, basically what those articulated buses or accordion buses, if you will, is doing in the middle of the circle of things. And that helped a lot. So another trick is if the user, especially if the user isn't the driver, is to show the road ahead. And this actually works in the real world as well. I tend to get car sick at times, but if I actually see the road and my brain can predict whatever turns there is, it's no problem. So here you can actually use things like transportations and blink to navigate the user so they don't have to get sick. Again, unless it's a part of the plot. And since there are so many individual factors that can affect your experience, and we're taking away so much of the interface from the user's eyes or face, if you will, we actually need to put so much more time and effort into user research and testing. And testing should never, ever, ever be skipped when it comes to AR and MR, and especially not when it comes to VR. And the testing should be preferably done in the beginning and really often. And it's best if it's the same type of audience that you're trying to reach that is actually doing the testing. And also, don't have your super VR friend that's super into VR test it, because he will already know how it's working. Heck, have your grandmother try it. She would probably be the best test subject ever. I have my mother try my things. There's a couple of things, tips and tricks that you can use to make the user's life a little better. And some of these guys will be fairly new to the games, so ease them into VR, for instance. Don't just put them smack in the middle where everything is surrounding them 360 degrees. Solutions like the Oculus Rift home screen, for instance, where you are in a virtual lobby of sorts, where you actually have to click to get into the game, is perfect. Tutorials on how-tos are often a necessity because these are new things for most people. If you are going on an elevator ride or something that is moving like a hot air balloon or something like that, it's a really good idea to put a still focal point so the user can actually concentrate on that while they're going up. And that will actually prevent a lot of cyber sickness as well. It's a good idea to let the user know if they're about to run into the wall. And now, many of these devices actually provide that for you, like the HTC Vive and Oculus Rift and stuff like that. And in mixed reality and augmented reality, you get those things for free because you see the real world, but it's still something that you need to think about so they don't trip over their cat like I do. And it can actually make the experience even more immersive for the user when they actually can trust that you won't send them down a cliff or something. Why you would actually play a VR game on a cliff, I don't know. Could happen. So in mixed reality, I told you before that the field of view can be kind of small at times. So to counteract that, you can actually make the items smaller, or you can put them a little bit further into the game. And what you have with the HoloLens is basically a printer page size on arm length distance. But I would also say that your brain is fantastic, because the brain will stitch it together, and you will automatically, when you have used the HoloLens for like an hour, you will automatically back away if the holograms doesn't fit inside the field of view and things like that. And the sound makes all the difference here. And smoothing should also be your best friend, especially when it comes to gaze and gaze cursor, if you're handling those things yourself. Because if you have a head-mounted display and you're trying to stay as still as possible, believe me, I have tried this with the HoloLens, trying to record another HoloLens. Your head is not still. It will feel really jittery like this, and that's why you actually need to have a little bit of smoothing on that. And when the user is ready to get out of VR, or they actually completed the game, ease them out. Don't just pull the cord like that. So fade to black is much more pleasant for the user. So where are these techniques heading? Well, the future will certainly be more immersive. We will remove obstacles. We will make things easier and smaller, for sure, like getting rid of heavy hand controllers and things like that, and maybe use gloves or just our hands. We already have techniques like the Kinect, where we can actually track our hands and movements. And we also have so many different cool sensors already today that we can incorporate in future devices. Like, we can feel if the palms are sweaty. We can measure your heart rate. We can hear the differences in your voice and if you're scared and things like that. Not to speak about machine learning and eye tracking. So you can have the character looking you in the eye. Imagine that scary game, the horror game where they're looking in your eyes. No, I'm out. I'm out. But that's the thing. Are you trying to cheat on your personal trainer experience? Or are you putting the building too up high so someone has to cheat? Or are you scared enough in the horror game? Because all of a sudden, you can make a game that is equally scary to me, who is a chicken, and to you, who's not, because they will measure. So for me, it won't for you seem as scary, but we will have exactly the same experience. So to sum things up, identify the experience, the tech, and the play area. That's important. And think about the interaction, both from you to the user and the user for your solution. And try to make it as comfortable as you can for the user so they don't get sick. And if there's only one thing you will take away from this session, it is testing, because you cannot tick all the boxes for everyone to have the perfect game when it comes to these XR devices. But if you make sure you test it enough, you can come pretty damn close. Thank you.